Okay, so can I just bring your attention to this one here? Okay, so hopefully they were all okay. This one here is a bit weird, okay, because I've asked you to find the inverse matrix. So let's have a think. Well, if I want to find the inverse matrix, how would I do that first of all? Good, so I do 1 divided by the determinant of that matrix. So what's the determinant of this matrix? Good, because you do 6 times 1 minus 2 times 3, or 3 times 2, that's fine. Okay. And then you switch these two rounds, so 1 goes there, 6 goes there, and you negate these two. This is -3 and this is -2. All right? Okay, that's just the standard procedure. Then we go through and tidy up. So, okay, 1 divided by, well, 6 times 1 is 6. Take away 6, and then that stays the same. Well, let's have a think. 6 take away 6 is 0. So you get 1 divided by 0. Can you do that? No, because what you're literally asking there is how many times does 0 fit into 1? It doesn't make sense. It's nonsensical. In fact, when you divide something by 0, this is undefined. This is an operation which is not allowed in maths. In fact, if you stick it in your calculator, it will just explode. Like, it will just throw you back a maths error, right? So if you try and do anything divided by 0, it doesn't have an answer, right? So therefore, we can't do this, can we? Like, if we can't do this, then we can't do this because we're taking something that we don't know and we're trying to multiply through this matrix. So because this doesn't make sense, we say that this original matrix has no inverse. Okay, so there is no inverse that exists for this matrix. Okay. Now this might seem a little bit weird to you because if you go back to what I was thinking about originally, 6 divided by 2 is the same as 6 multiplied by a half. Are you happy that if we take a number and we try and divide by another number, we should always be able to find an inverse of this number here? We should always be able to find an inverse of this. But this is weird now because with matrix multiplication and with matrices, there's some matrices out there where you cannot find the inverse.
You just need to write no inverse.
Absolutely.
Like
there's no inverse. Yeah, absolutely. And the reason why there is no inverse is because the determinant, the thing on the denominator, is equal to 0. So I guess the first thing that you should do before you do anything else is check the determinant. Check the determinant of your matrix. If that comes out as 0, it means that there is no inverse. Okay? Now I'll give you a term just because you might see it if you're reading it in the book. We call this matrix, because there is no inverse matrix that exists, there's no other way that we can invert it, we call this matrix singular. It's the only one. Okay? So if the determinant is equal to 0, then the matrix is singular. Okay? In other words, it's the only one that exists. There is no inverse matrix. Okay? So just be aware that you're not always going to be able to find an inverse matrix. All right? So don't be surprised. And the way to check that is check the determinant first. If the determinant comes out 0, you don't even need to bother with all of these lines. You can just say the matrix is singular. There is no inverse. Okay? In other words, I can't find another matrix which, when I multiply it by that, gives me the identity matrix back. Okay? Now, just very quickly, before we move on to the last ever thing that I'm going to teach you, okay? Have a think about this. Have a think about this. What was I going to say? I know what I was going to say. Let's have a think about this inverse. Let's have a think about defining the inverse of matrices, okay? Can I always find an inverse for a matrix? So, for example, what is the condition of finding the inverse of a matrix? So if a matrix looks like this, then I can attempt to find an inverse, okay? But what if I added an extra row or an extra column to my matrix? For example, I go 8 and 10 here, okay? How do I find the inverse of that? I can't, okay? The reason why I can't is because this is a non-square matrix. Okay, it's a non-square matrix. Okay, so the condition to find an inverse, if it exists,
can be only 2 rows and 2
well,
columns, yeah?
you could also have 3 rows and 3 columns, or 4 rows and 4 columns, or 5 rows and 5 columns. Basically, as long as the columns are the same as the number of rows, then I can try and find an inverse. Okay? So it needs to be, to find an inverse of a matrix, the matrix needs to be square. Okay? So in other words, the number of rows needs to be equal to the number of columns. Okay? So you see with this example here, what are the dimensions of this matrix? It's a 2 by 3, right? So because the rows aren't the same as the number of columns, then I can't even attempt to find an inverse here. Okay? So just be aware, there are some matrices out there where you can't find an inverse because the determinant is equal to 0. But also, if you even just want to try and find an inverse, you need to make sure that the matrix is square. Because if you think about it, it's this property here. This tells me that that's the case. If I take an inverse matrix and I multiply by the actual matrix, that needs to be equal to the identity matrix. Okay? And if you think about it, the identity matrix is square by definition. Yeah? Because it's just the leading diagonals are all 1s. So this, for example, would be the 3 by 3 identity matrix. Okay? So if I want to find the inverse of a matrix, first thing I need to check is the dimensions. Is it a square matrix? Are the number of rows equal to the number of columns? If yes, I then need to check if the determinant is equal to 0, because if the determinant is equal to 0, it's a singular matrix, there's no inverse that exists. If not, then I can try and find the inverse.
But if it will be 4 rows and 4 columns, we can do it?
Yes, absolutely.
How
We're not going to look at that. So in this course, we only look at matrices which look like this. Okay, so 2 by 2. We're not going to look at it. 2 by 2, that's as far as we go with finding the inverse of a matrix. Because as soon as we start looking at 3 by 3s, it's a whole lot harder.
You just shows that it will not be so, yeah?
It's not as easy. It's possible, but it's not as easy. And in fact, you can calculate a 3 by 3 inverse by hand, just about. It's a little bit of work, but you can do it. As soon as we start getting to 4 by 4s or 5 by 5s or 6 by 6, we just get a computer to do it. Okay? Because a computer can do it like that. Right? We've got row operations which enables a computer to do it like that. But yeah, by hand, I think just understanding a 2 by 2 is enough. A 3 by 3, like I say, can be done by hand. It's a little bit more work. But yeah, anything beyond that, we just get a computer to do it. Yeah. But I just want you to understand the idea of an inverse. Yeah? Which is why we just look at a 2 by 2.